Wow! Gosh, I made it. I made it by a split second. That was great. So, hey, welcome back, SQL in the City. We are going, and we're going. This is going to be awesome. Let's talk about SQL in the Cloud City, right? Now, what we're talking about now, Rogue One, right? Nobody? Okay. Anyway, rapid diagnosis of SQL Monitor. No, rapid diagnosis of SQL problems with SQL Monitor. Let's talk about it. My name is Grant Fritchey. I work for Redgate Software. This is my contact information. If you have questions after today about anything DevOps, we've been covering that quite a lot. We're going to be talking SQL Monitor now, query tuning, some fun stuff around that. If you've got questions on this stuff, please let me know. I want to help. You now have my contact information. This is my blog, my email, my Twitter handle. You can get in touch with me. I will answer your questions to the best of my ability. All right, let's keep going. So we've got some goals today that we're going to go through. Good, this is on. I want to use SQL Monitor to identify pain points. I want to talk about basically how we deal with the fact that, you could get a phone call, right? You can get that phone call on SQL Server. Things are offline. There's a problem. Oh my gosh, what do we do? That's a great way to respond, but that's very responsive. Don't you want to be working in such a way that you're ahead of the game? That's why we're going to do monitoring. That's why we're going to put these kinds of things in place. I want to show you how to walk through, follow some information, track through the maze of data that's there, and then nail down where the issue may lie. And then use those same tools to at least propose a solution. I'm not going to fix the problem, but I'm going to identify a potential fix for the problem. And we'll discuss not only what the potential fix is, but why it's only a potential fix. All right? Because you're also going to want to go back and retest everything. You're not simply going to get some bit of a piece of information and apply it blindly. That's crazy. We need to focus, we need to measure, and let's talk about it. So what do we want? What do we want out of SQL Server? Well, we want it to fly. We want it to work. We want it to be online, available, and working well. We want our businesses to continue to function. We want everything to work. We want the rocket to take off and do what it's designed to do. This is what we're aiming at. This is our goal. So sometimes, what do we get instead? Every once in a while, things go pop when they're not supposed to. It happens. It's not that big a deal, but it's something that, it just occurs. So the real question is when things go pop, when stuff breaks, when stuff goes south, when you get that phone call, oh my gosh, there's something wrong with the server. What do you do? Well, option number one, cry in the corner. Just go and curl up in a ball and try to hide. Heck, we're DBAs, we don't want to talk to anybody anyway. We can just go away someplace and hide. All right, that's not going to work for most of us. So what do we do instead? Well, let's talk about measurement. What we want to do is we want to do measurement. You want to do design, you want to do measurement, you want to do thoughtful process. This is all about coming at things from an attitude of knowledge, an attitude of understanding, and working through what knowledge and measures we have. If we don't have knowledge and measures, we need to get them in place. So if we're going to put them in place, we're talking about monitoring. Now, we've talked about DevOps and the DevOps role all day long. We've been going over and over this stuff. The whole idea of developing code, building the code using the various tools, validating and testing the code to ensure that what we're getting is in place, packaging all that stuff up and then releasing it out into our production environment. We have not, and we also talked about provisioning. We started out the day talking about provisioning with SQL Clone, which is a really cool tool you got to check out. What we have not talked about is the concept of monitoring. We're going to monitor this. The whole DevOps process is a circle. It's something that's constantly going on. Your role, if you are a DBA, if you are a data pro responsible for production environment, your role is still part of the DevOps role. As Alex just said, if you were watching his session, it is both dev and ops. That's the whole idea of DevOps. It's merging the two processes. It is communicating across these two processes, acknowledging that you were involved with both. So monitoring is a fundamental part of DevOps, and you need to make sure that that we've got that in there. Now, SQL Monitor is a monitoring tool from Redgate Software, and it gives us a lot of these measurements. It gives us a lot of these goals and ideas of what's going on. So where does it start? Well, it starts off with your enterprise. It gives you a whole view of your entire enterprise, everything available, and its status. Is it online? Is it offline? Have there been alerts? If those alerts are red, that's bad. If everything's good, it's green. If things are it's in the middle. Excuse me. Okay, maybe not. Wow, that was weird. Thought I had to sneeze. Anyway, if, this is sort of management speak, red bad, green good, but it's still, the idea here is that you've got an overview, what's going on, and you get to break these down. What does my production environment look like? What does my staging environment look like? Because it actually matters whether your staging is online or not. What does QA look like? Because to the QA team, that is production. What does dev look like? Because to the dev team, that is production. We need to know whether or not those guys are online, and SQL Monitor can track all that for you. What else does it tell you? Well, it gives you information about the alerts. When things go bad, backups have failed. Red line, right? That's a bad thing. A SQL agent job has run long. That's interesting, but Or, maybe just informational. Hey, somebody logged on and we're not sure where they came from. Hey, that might be important. We can get alerts on all these different things. Now, what else can it tell us? It can go down into the metrics, right? Into the specific measurements. What is going on with CPU? What is going on with disk weights? What is going on in various processes throughout the thing? And most important, not simply what is going on, but the ability to compare today to yesterday, this week to last week. Because when someone says, hey, things are slow on the server, it's not simple enough to go, okay, things are slow. Slow compared to what? Now, what you can see there on the screen is what we call a baseline, and that is a normalized structure looking back over 7 weeks. So you can see that little red spike, which occurred last night, is not that big a deal because that little red spike occurs every night around the same time. What is that? That is a backup process affecting how disk I/O goes over the day. Hey, I kind of don't care that that's a big deal. Right, but we've got the ability to compare that spike from last night to a preceding time, to a series of preceding times, and that gives us information so that we're no longer just responding to something that we saw, but we're measuring and making decisions based on those measurements. And that's our goal. A new thing that we're introducing now is the ability to create some canned reports that you can take all this stuff together, create a series of measures, put them together into a single report, and then email it to your boss, email it to yourself, whatever, keep a track of it, and put it into a canned package so you can move it off and put it someplace and have it available for later. It's a great way to figure out what's going on over time, and it's a great way to report uptime and all kinds of fun stuff like that. And so those are all put together inside of a canned report. But now, let's go play, because playing is a lot more fun. Now, I've got a system, I've got a system that I clicked in the wrong spot. I've got a system showing some time and various behaviors that I've put together. Now, this is my local server. It is only running my local instance of SQL Server, so the monitoring on it's not 24/7 because I will shut down my laptop at night, and so you won't see everything that's going on. Let me just zoom in a little bit. Now what we've got here is over a period of time, I put a load on the system, and that green line represents some I/O, the blue line represents some CPU, and you can see where at one point my load thing got turned off and the green line dropped, CPU shot through the roof. But what I want you to focus is right there in the center, where there's a severe spike in CPU. Let's pretend that around 7 a.m. when that occurred, I got a phone call. Or maybe even after 7 a.m., probably 8 or 9 a.m., I may have gotten a phone call saying, hey, you know what, at 7 o'clock we were running some queries and we hit an issue. With this, you can immediately go in, drill in, and take a look and say, okay, well, I can see that there was a load at 7 o'clock. There was like, the line before and after that little blue spike is pretty steady state. There's a lot of activity going on. But right around the time you say that there was an issue, and we can even narrow it down and say, what time was that? Oh, that was at 6:54. 7 o'clock. For once, that phone call actually was accurate on the time, right? How weird is that? you know that you got a spike on the CPU to around 80%. Now that's a significant spike. That's using up quite a lot of the CPU there. And by the way, I know that that's a higher spike. It's a demo machine. Bear with me, all right? Let's work together on this. When we look down, we can see over here that there was a steady state except for that one big spike in the middle, and it's based on this highlighted area. We see the information down here. Memory, steady state, no big deal. We're using up every bit of memory we possibly can. That's what SQL Server does. I/O, it's doing stuff, but nothing bad, nothing abnormal. And basically, there's a pretty consistent behavior. Same thing goes with the network. Whoops, that was a weird little jump. Oh, it's my mouse. So next down, we can go down and we can start looking at the top 10 queries. And we can see by duration each of the queries that are going on. Now let me zoom in a little bit so you guys can see. Now there's some sort of system query here looking at the extended event session targets. Maybe that's important, maybe it's not. It got executed 24 times. Duration's a little long, a little bit of CPU. From the duration, and that's an average duration over that period, maybe that's an issue, maybe it's not. We've got some other queries though. Let's take a look in there. We're pulling out the plan handle. We're looking at XP address, and we're looking at, there's an actual query that was called 11,100 times. Huh. Okay, that's quite a lot. And there's another query going against the common table expression that was run 1,000,000 times. Maybe that's an issue. Let's say that we know this system. I know that the query that was called 1,000,000 times has already been tuned fairly well. It's got a good set of indexes on it. And if you look at the average duration at 4 milliseconds, I think we're okay, right? Not a big deal. The other one, maybe or maybe not, it's an issue. Let's zoom back out. It's hard to know what's going on based on just queries. So based just on duration. So let's also sort based on CPU time. Now if we look, well, we see the extended event session query is still up there. Used about 112 CPU. That's interesting. We see that there's another query and it used a little bit of CPU. And then, hey, look at that. Number 3 is that other query, the one that we don't know about, was executed 11,000 times and it's using quite a bit of CPU time on average too. Well, let's sort again. Let's sort on logical reads. Now if we zoom back in so you guys can see, we'll notice, hey, look at that. There's that system query going for the query plans. And there's that address query again. Now it's bumped up even higher. It's got 349 logical reads. It's been called 11,000 times. I'm getting more and more interested in this query. It looks like a lot of stuff is going on with it. Heck, if you'll notice, the one query that we were worried about, that one that was called over 1,000,000 times, it's bumped way down. It's hitting almost no logical reads at all. Why? It's a fairly well-tuned query running in 4 milliseconds. Wow, I'm seasick. I don't know about you guys. We know about it. The number of logical reads it hit is 91. We've got knowledge about this query already, and we know that it's running the way we expect it to, even though it's called a lot. And yeah, if we could tweak that and tune it better, that might reduce our overall load. But we know about that query. It's not something we don't know about. That other query, that address line query, that's popping out at me. I've never seen it before. I don't know why it was called 11,000 times. Something's going on with that. It's showing up over and over again in our sort. So we've got something there we need to take a look at. So let's take a look at it. We'll click right on the query. We'll zoom in. We see that the query has got SOS scheduler yield. Oh, wait, what? SOS scheduler yield? You mean it's waiting on the processor? Huh. Didn't all this launch off of a CPU spike? Yeah, it did. CPU spikes. Wow. Okay, so a number of CPU spikes caused by this thing. The query itself, it's going from the person address table, state province table. It's doing a filter on the @city column. Seems okay. I mean, it's nothing exciting, but we've got some information about it now. Now we can drill down. There's other information available to us. Hang on, get off my screen. We can look at SQL metrics. We can see what's going on across all kinds of stuff. We can see page splits, compilations, all kinds of other information. And you'll notice every one of these has got, there's something happened at 6:53. There's something happened at 6:53. around 6:53, 6:54 a.m., something happened. Might be that one query that we've never seen before that got called 11,000 times. Anybody guessing at that? Me too. Mainly because I know I ran that query 11,000 times at 6:54 a.m. I know I'm cheating, but that's my job. The other metrics aren't going to tell us as much. So, basically we've kind of narrowed down. We know roughly when the problem occurred, and we've got a good idea what the problem might be. It looks like that query is giving some issues. So let's take a look at the query again. And let's notice I kind of glazed by this just to show you some other information. The fact is we can actually look at the query plan. If we look at the query plan, it's not a bad plan. It's not complicated. It's not hard to understand. We've got a select operation. It's pulling from a merge join, which goes from a clustered index scan, a sort, and another clustered index scan. Now, if we look at this, this is Super Team is showing us this information. It's built right into SQL Monitor. If we take a look at it, you can see that the most expensive operation was 88% was a clustered index scan. And then we have some other data-heavy operations moving a bunch of records around, 434 records. And if we go back over here and we look, and we can see the, zoomed in, things always act a little funny. There we go. Got to fly like a pilot. Minor adjustments, minor adjustments. 88% is that one clustered index scan. Now that's interesting. We have another clustered index scan, but it's only doing 1.33%. Now these are estimated values. We don't know what the actual measures are, but you can look at them and kind of get an idea. This one's moving 100 records. This one's moving 434. If we take a look at the properties, scroll down a little bit, the table only has 181 rows in it. We can tell that by looking at the cardinality. So it moved 141 of 181 records. 141 records, there's probably not a lot moving out of there. Let's take a look at the properties on this one. Scoot over, scroll down. And now we see a cardinality of 19,000. I suspect a scan against 19,000 rows is probably around the neighborhood of 88% of the cost compared to a scan of 100 and some odd rows. Anybody agree on that guess? Raise your hands. No, raise them. I can't see. Okay. I agree. It's moving a bunch of data. 19,000 rows is coming back and forth. That's a lot of stuff moving around. That concerns me. Now, I'm not done with my concern. Let me zoom back out a little bit. Hide the properties again. Remember that? Oh, no, let's zoom back in so we can see it. There's a sort. Why is there a sort? Well, let's go back up to the first one. Again, take a look at the properties. Always back into the properties, always back into the properties. Properties are what we're looking at. Hey, look at that. It's ordered is equal to true. Interesting. Well, it's going to a merge join. Merge joins are very efficient. Whoops, wrong key. Merge joins are very efficient. So a merge join takes ordered input from one, ordered input from another, and puts them together. Well, we've got ordered input from one, and we've got a sort operation. I know what's going on, but let's prove it. We'll go over to properties. We'll scroll down. Ordered is equal to false. Uh-oh. What happened? Well, it's scanning an index. Where is it scanning? I don't know. I mean, it's kind of hard to tell what's going on. What if we, I don't know, again looked at the properties? Predicate. Oh, it's at city. So, what's this index on? Well, this index is on address ID. We're filtering on city. Huh. I wonder if we could put an index on this and it would help. Just guessing. Or maybe, let's zoom back over here. Look at that, there's a warning. Missing indexes, missing index could improve the cost. Let's click on that and see what we've got. Missing index, it suggests use AdventureWorks 2014, go, create non-clustered index, and the index name is, by the way, there are consultants around the world who sing hallelujah every time they see an index on one of your tables named name of missing index, sysindex. Please, please, please stop them singing. Rename the index before you create it, okay? We're all asking, begging, please get that done. All right, so we're going to create an index and it's going to be in the address city table. Awesome. And in theory, Microsoft's suggesting through the missing index information that it's going to move this query better by 80%. Whoops, didn't mean to do that. Click the wrong X. What happens then? You get bad stuff. Okay, let's close all that down. So, what we've now got is a suggestion for a missing index. I suspect we've got our solution. However, we don't. What we have is a starting point for testing our solution. We're not actually going to implement this. What we are going to do is we're going to go back to our dev system. And we're going to take a look and see, like, okay, so if this index were implemented, what would happen? How does it affect other inserts? How does it affect updates, deletes? Does it impact other parts of the system? Are there other queries that need the city column to be filtered? Let's check all that stuff out before we make a decision on this one missing index query. However, 11,000 calls, if this is going to be a regular thing, it's spiking the CPU, it's causing waits on the CPU, our CPU is already under load. If we start seeing this a lot, this thing could become a major issue. So we've got indications that are going to walk us right up to creating this index. But is this index going to be helpful? Well, we won't know without testing. I cannot tell without testing, but I can make an educated guess. And I'm going to make that based off the query. So if we put an index on the city column for address, what's going to happen? Well, the optimizer says, I can use that index to retrieve data, and it will. If we were to put this together, put it inside of a test system, put it together and try it out, what we would see is it would take that index, and it would do an index seek, it would go down there and find the rows that it needed, and that's great. And then it would add another couple of operators. The next operator would be a probably nested loops join, and the other operator would be a key lookup. What's it doing? Well, if we notice there, we're pulling out the address ID, the line 1, line 2, city and postal code, all from the address table. If we just put an index on city, we still have to go back to the clustered index to retrieve the data. We might need an include statement on the index. Maybe. This is all about testing. This is all about validation. We need to test and validate whether or not that's true. Probably it is, but that adds to the impact. Can we trade disk space for performance? That's a decision you'll have to make and measure using the same set of tools that we've got in front of us. Okay? So now we've got a proposed solution all from SQL Monitor. Never having left SQL Monitor, we've at least proposed the point of a solution. So let's talk about it. What did we do? Well, we opened up SQL Monitor and we spotted a spike. We spotted a problem, especially because we get that phone call. We think something happened at 7 a.m. Sure enough, something did happen at 7 a.m. There was clear spike on the CPU. We had a problem. We drilled down on the details. We started looking through, and sure enough, there was compiles that occurred at 7 a.m. that compiled stored procedures that obviously hadn't been compiled before. We saw waits at 7 a.m. Around the CPU. We saw all kinds of stuff occurring at 7 a.m. We filtered our query various ways so we could see, well, okay, so CPU, which ones use more? Okay, disk, which ones use more? Duration, which ones use more? Which ones were called most frequently? Which ones lined up frequently? What came up? What data presented itself? What measures came up to us? We then investigated that data. We drilled down, took a look at the query. We took a look at the stored procedure. We dug through the information and data at hand so that we could, start understanding what was occurring. And then, using the information provided to us, we identified a possible resolution. Possible resolution. I probably should have put possible in the slide deck. It says A. But we identified a possible resolution. So taking the problem and identifying where that problem occurred, drilling down on the details of the problem, looking at the data in various ways, slicing it through various ways using SQL Monitor, investigating the information provided to us, and sure enough, the one query that we looked like that we hadn't seen before that was showing up had waits on the CPU, and then drilling into it, we could see that this query had issues, clearly needed an index, and if we had put that index in place, at least it would work better. Probably we'd want to modify that index to make it work best. But regardless, we were able to go through all this stuff from SQL Monitor and put it together. So, what were our goals of the session today? Use SQL Monitor to identify primary pain points of SQL Server. Hopefully we showed how that can be done, how that occurs, where you can drill in and find that information. Follow that information to localize where things were happening. That's pretty much what we did. We spotted, the area that we were concerned with. We were able to drill in on it and make some decisions there. That led us down to the path we needed to be. With that, we then took the tools that we had at hand and tried to put it together so that we could propose a solution that would bring us to a resolution. That was the goals of the session. Hopefully the goals and what we did matches up. And so our future looks bright, right? The chute has deployed, everything's going to land, the rocket flight is successful. Yeah, no, rocket flight's not exactly a great paradigm for SQL Server because we kind of want it to fly continuously, not fly and then come back down. But, hey, pretty pictures, and it's a presentation. So I hope you enjoyed talking about SQL Monitor. The future looks very bright, and let's answer a couple of questions. First up, this isn't related to Monitor, but does SQL Toolbelt work with Azure SQL, can't even say it. Does SQL Toolbelt work with Azure SQL Database? I'm sure it works with as infrastructure as a service, but what about SQL Azure? Hey, I am very, very, very excited and pleased to announce that it absolutely works with Azure SQL Database. It even sort of kind of works with Azure SQL Data Warehouse, but not completely. There's some issues around that one. But Azure SQL Database, absolutely, we support it all the way. SQL Prompt works with Azure SQL Database. Yeah. But compare, data compare, all of them. Matter of fact, compare and data compare is a great way to do some migrations and stuff to Azure SQL Database. Now, if you want to try out SQL Monitor, you can. We have a live website, sqlmonitormetrics.redgate.com. That is SQL Monitor is running all the time on our SQL Server Central database. So our servers are online. Our monitoring tool are monitoring those things live. So you can go in there and play if you go to sqlmonitormetrics.redgate.com. Now, I did put up my new blog post, and the blog post at redgate.com. Oh, that's way too long to say out loud. I'll get it wrong. Go to the Redgate blog at redgate.com. You'll find my Monitor articles, the very top one, and it basically walks you back through the scenario I gave with a lot more detail than what we went over here. And so all that's put together, and that's ready to go. Do we have any other questions that have come up around this stuff? Okay, excellent. That's good to know. I want to thank you guys. I've got one more session a little later. It's going to be pretty cool stuff. Other than that, we're up with a different session coming up right now, and thank you very much. The SQL in the City. We're having fun.